All right, so this is a guide on converting non-terminating or repeating decimals into fractions. Before we get into the steps to solve, we need to go over our rule of nines. And the rule of nines is just how we write these non-terminating elements as fractions. So whenever the repeating element or the number that gets repeated is only one digit, for example, 0.88888 repeating, you can write that as the element over 9. So 8 over 9 is equal to 0.8 repeating. When the element that is being repeated is 2 digits long, for example, 0.26262626, you can write that as the two elements that are repeated over 99. And then this pattern continues on. So for any where it is repeating 3 elements, 0.388388, you can write the repeating element over 999. The thing to note, though, is that the decimal point must always be directly preceding the repeating element. So if we had like 0.08 repeating, that is not the same as 8 ninths. And that's where our steps to solve come in. The first step is to move the decimal next to the repeating element. For our example, let's do converting 1.08 repeating with only the 8 repeating, so 0.0888, into a fraction. So the first step is move the decimal next to the repeating element. So we move it one place value over so it's next to the repeating element. We're going to count how many place values we moved it and box it in for later. So when you move the decimal point 1 point to the right, going from 1.08 to 10.8 repeating, that means you've moved it one place value, which means you multiplied by 10. We're going to box this in because we're going to need to undo whatever we do at the end. Otherwise, our fraction is going to be 10 times too big. For step 3, we're going to write our repeating element as a fraction using the rule of nines. Well, look, now that we have 10.8, the decimal is directly preceding the repeating element, and we can write 0.8 repeating as 8 ninths. So now we have 10 and 8 ninths. Step 4 is to convert whole numbers to a mixed fraction. So we're going to multiply, because we have 10 wholes, and a whole is 9 pieces, so that's 90 plus 8. So now we have 98 over 9. And then the last step is to undo whatever we did in step 2. So when we move this, we multiplied by 10, which means we now need to divide by 10. Remember that to divide by 10, that's the same as multiplying by the reciprocal, which is 1/10. And so our answer is going to be 98 over 90. And if you plug this into your calculator, you're going to find that 98 divided by 90 is 1.08 repeating. Great. Let's do another. Let's do 2.036, where the 6 is the repeating element. Sometimes I find it helpful to kind of write the part that repeats, just as a reminder. We need to move this decimal point next to the repeating element, which means we need to move it 2 places, which means our new number is 203.6 repeating. Since we moved the place value over 2 places, that's the same as multiplying by 100. And you can check this by seeing, well, what do I have to multiply 2 by to get to 203, which is about 100, right? So since we did that, we're going to write times 100, and we're going to box it in. So when we get to the end, remember we need to end up dividing by 100 to get back to our original place value. Now that we have this rewritten with one repeating element, we can rewrite it using the rule of nines. 203, and since our repeating element is only one number, it's going to be 6 over 9. Okay, we're going to do step 4, which is converting our whole number into a mixed fraction. So 203 times 9, I'll do it real quick. 203 times 9. So 1917 plus 6. So that's going to be 1923, approximately, over 9. And then we are going to undo whatever we did in the beginning. Okay? So we are going, since we multiply by 100 here, we have to divide by 100, which is the same as multiplying by a 100th. And what you get is 1923 over 900. And if you plug this into your calculator, out pops 2.036 repeating. So we'll box this in and check it off. All right, let's do one more. For our last one, and I'm going to rip this real quick. Okay, just so we have it handy, we're going to do one where the repeating element is more than 1 digit long. So let's do 4.0024 repeating, and we're going to have both the 2 and the 4 repeating, which means this would look like 4.00242424. Okay? We need to move our decimal point over 2 place values to get it next to the repeating element where it starts. So that's the same as multiplying by 100, and you can check how many zeros are there. Does the number of zeros match the number of jumps you made? If so, you know you've multiplied by the correct place value. We're going to box it in so we remember to undo it at the end, and then we're going to rewrite with our new place value. So since we moved it, it's going to be 400.24 repeating. Okay. Also, and then we're going to follow step 3. Write your repeating element as a fraction using the rule of 9. So since our repeating element is 2 units, it's going to be over 99, 2 nines. So that means it's going to be 424 over 99. Okay. We're going to convert this into a mixed number, so 400 times 99, and I apologize, sometimes the multiplication is going to get a little nutty over here, okay? 0036, and then we have 0036 again, so we're going to end up with 39,624 over 99. Okay, and then because we multiplied by 100 at the beginning, we must divide by 100 at the end. I'm going to do this backwards because otherwise I'm going to run into this. I apologize. Same as multiplying by 1/100th. So what you end up with is 39,624 over 9,900. And you can simplify this. I can tell this can be simplified because these both end with even digits, which means you can at least divide these by 2, probably more than that. But that's it. And if you plug this into your calculator, you're going to end up with 4.0024 repeating. And the reason I can tell that this is the correct answer for this is that, let's estimate real quick. This number is pretty close to 40,000. This number is pretty close to 1,000. 40,000 divided by 1,000 is 4 with some change, which is what this is. So I know this is correct. Let me know if you have any additional questions.